Okay, so let's go ahead and take a look at this particular problem, 25 times 44. So go ahead and try this with me. We're going to first use the area model and then see how that relates to the type of partial product algorithm. Okay, so let's go ahead and make a rectangle and label one part 25, but in a way that'll help us visually see what's happening when we're multiplying. So part of it's going to be 20 and part of it's going to be 5. 5 is much smaller than 20, so 20 is going to be the bigger part of our rectangle. Okay? And then I'm going to get the other side of the rectangle as 44, and so I'm going to have a 40, and I'm going to have part of it be 4. So 40 is the bigger part, 4 is the smaller part, and now I finish my rectangle. I finished my parts all the way across, and now I have 4 parts inside the rectangle. And now I'm going to go through and label each part. So if I go to this big chunk, the big chunk would be labeled what? You go ahead and decide. Pause the video if you want. And then now I'm going to write it in. It is a 20 by 40 rectangle, so I'm going to label that as 20 times 40. And then I'm going to get that product, looking at the 2 and the 4. 2 times 4 is 8. And then I'm going to attach the 2 zeros. So I'm at 800. Now I'm going to go over to the right rectangle over here. And I have to think about what dimensions this is. And this is a 5 by 40. So I'm going to write that in, 5 times 40. And I'm going to look at those front 2 parts of my numbers. 5 times 4, that's 20. And then I have 1 0 to attach at the end. Okay, now I just have my lower 2 rectangles. So I check what this big long one is. This is a 4 by 20. And now I have, it's kind of similar to the one above it, 4 times 2, which is 8, but here I'm only attaching 1 0 to it. And then my final rectangle is the smallest one, and that's a 4 by 5. Again, similar to the one above it. So 4 times 5, 20, and I don't need to attach any zeros. So now to get the total amount of little squares that would exist inside here, remember we talked about that, if you were to draw those tiny little squares, it would take forever. So this is a nice model to be able to not have to do that. So now I'm going to take all my 4 products and add them together in any order you want. So I'm going to add the 800 and 200, and I'm at 1,000. And then I'm going to add the 80 and the 20 onto that. So I'm at 1,080 and add another 20. And there I have my final answer, 1,100. So now let's go ahead and take a look at what that looks like using the partial product algorithm. And I want to show you this one before we get to the shortest method. Okay, so you can see what's happening. So first, I'm going to multiply the 4 with the 5. So I'm going to go ahead and write 4 times 5, because that's what we did first, and that is 20. I'm going to write the whole thing down here. Okay, and we notice that 4 times 5 happened right here in our area model. So there it was, and now I'm going to go ahead and multiply 4 times this 2. But remember, this 2 is not just worth a 2. That 2 represents the number 20. So really we're multiplying 20 times 4. And 20 times 4 is 80. And we can see it exists right over here on the left of that area model. So we actually did both of these multiplications first by this factor of 4. And now we're going to go through and multiply this 4 which represents 40, you can see it over here, with the 5. So 40 times 5 happens right here. So I'm going to go ahead and write that under it. 40 times 5, and we're at 200. And as you noticed, and as we pointed out, it's right there in our area model. Okay? Now there's one big chunk still left to multiply. It's right here, the 20 times 40. Do you see it over here? Do you see it happening? Here it is. You have your 40 times your 20. So we're going to go ahead and write that in, 40 times 20, and we know that's 800. So I'm going to make it green. I'm going to color that in green, just so you can visually see what we just multiplied. And now we add it all up together, and these are the same things we got over here. Okay, so we're going to get the same answer. And now let's go ahead and also do it using the standard algorithm. So now I'm going to use blue. So now we have 25 times 44. And instead of writing all these products out here, the partial product method, we're going to try and regroup here so that we can do it in just 2 steps. Okay? So first, we have our same idea. We're going to take this 4 and multiply it by the 5. So 4 times 5 is 20. But we're only going to write the 0 here, and we're going to regroup the 2 tens in that tens column over there. And now I'm going to multiply the 4 with the 2, and I'm going to keep that just in my mind as a 2. So 4 times 2 is 8, and then add on 2 more, 8 plus 2 more, and we are at 10. Okay? So we have gotten in our first line 100. And if you notice right here, this orange, if you had 80 and 20 together, what do you get? You get 100. Okay? So that's because we were multiplying 25 by this factor of 4. And that's what we are doing right here. This dimension is a 25 by 4 rectangle. So now we still have to multiply this 4, and remember that's worth 40 over here, by both the 5 and the 2. So because this 4 is in the tens place, we're going to write in, if you remember, a 0 placeholder, and then we start in and we do 4 times 5, which is 20. So we put down a 0 and regroup the 2. And we already used this 2, so I'm going to put a 2 above it. Okay? That 2 is from our first step. And now we multiply 4 times 2. That's 8. And add on the 2 more up here. And we are at 10. So now let's check. We got 1,000 right here. And if we go to our area model, the stuff in green, if you add 800 and 200 together, that's 1,000. So we just did this in 2 steps instead of 4. Okay? And when you add it together, we're at 1,100. The same exact answer. So pretty awesome. I'm going to show you one more way by using, I set this up strategically because this 25 is super special number. 25 is special because it represents what in your mind? What in money? Money, money, money. 25. What's so special? Oh my gosh, a quarter is worth 25 cents. So in your brain, another method here is to say, oh, a quarter, 0.25. I can think of quarters, and if I had 44 quarters, how much money would that be? Oh man, 44 quarters. I don't know. Do you? Well, we could start out with 4 quarters is $1, 8 quarters is $2, and keep going until we get to 44 quarters. Or you would say 0.25. Okay, what is that as a fraction? That's a quarter. That's a fourth. So you could also think of it that way, a fourth of 44. So now you're thinking, okay, 44, I need a fourth of it. So if I take 44 and split it into 4 equal parts, what would each of those parts be worth? They'd all have to be the same number. So go ahead and just make a guess at it. Let's say it's 10. If all these were 10, that would give you 10, 10, 10, 10. That would be 40. Super close to 44. So let's just bump it up one more. 11. What if it were 11? So 11 plus 11 is 22. And another 22 would give you 44. That's it. So a fourth of 44 is 11. Which means if you had 25 quarters, or not 25 quarters, if you had 44 quarters, you would have $11. So that helps you figure out the answer to this problem. Because if you, here we go, we're almost there, stick with me. If you think of this as 0.25 or a quarter times 44 is 11, then to get to this answer, 0.25, I'd have to multiply that by 100 for it to be worth 25. So then I'd have to take 11, multiply that by 100, and that would give us our answer to 25 times 44. And 11 times 100 would be 1100, which is what we got down here. Okay? This is just a method to show the cool factor of quarters whenever you see a 25 in a problem. And don't worry if you don't understand that right now. All right? Okay. My advice would be to run this video again and try this problem again, or try a problem similar to it with 25 in it. Okay? All right. Good luck.